Right now, as you're watching this, parts of California's coastline are slowly tearing apart. Not metaphorically,
spiking on sector
not
4,
someday,
correlate with the log.
physically,
Copy, aligning
silently,
now, it's clean.
relentlessly.
Good, monitor for drift.
Along a stretch of cliffs north of Big Sur, rock that held firm for thousands of years has begun to fracture like dry bone. Hairline cracks widen by millimeters each month. Entire slabs of earth shift imperceptibly toward the Pacific. No alarms sound, no sirens warn the towns above, but satellites see it. Sensors feel it. And scientists are watching something they can't ignore. The first signs didn't look dramatic. A slight distortion in satellite radar scans.
Confirmed, holding steady.
A subtle displacement in GPS ground stations anchored to bedrock. Numbers drifting out of alignment by fractions of an inch. At first, researchers assumed instrument noise, calibration error, atmospheric interference. But the anomalies kept repeating. Same locations, same direction of movement, same slow slide toward the ocean, so they looked closer. Using a technology called INSAR, interferometric synthetic aperture radar, scientists began comparing high-resolution satellite images taken weeks apart. When layered together, the images revealed a pattern invisible to the human eye. Coastal rock faces weren't stationary, they were creeping, not collapsing, not yet, but moving, like a massive geological breath being drawn in. The Pacific coastline feels eternal when you stand on it. Wind whipping, waves crashing, cliffs towering above the surf. It looks immovable, but that stability is an illusion created by human timescales. In geological time, coastlines are among the most unstable places on Earth. California sits on the boundary between two colossal slabs of the planet's crust, the Pacific Plate and the North American Plate. They don't glide smoothly past each other. They grind, they snag, they lock. Pressure builds for decades, sometimes centuries. Then suddenly they slip. That grinding force doesn't only trigger earthquakes, it fractures rock deep underground. It weakens cliff foundations. It redirects underground water. It slowly dismantles the structural integrity of the land itself. And when that weakening reaches the surface, coastlines begin to crack. In places like Pacifica, Daly City, and parts of Monterey County, erosion has already eaten away entire sections of bluff. Waves strike the base of cliffs with the force of small explosions, again and again, hollowing out rock that once seemed indestructible. Winter storms accelerate the assault. Each wave removes grains. Each tide pulls fragments. Each season steals inches. Over decades, inches become feet. Feet become collapses. But erosion alone doesn't explain what satellites are seeing now. What concerns researchers is the combination of forces happening at once. Sea levels along California's coast have been rising steadily over the last century. Even small increases allow waves to reach higher sections of cliff than before. Water seeps into fractures, expanding them. When temperatures fluctuate, trapped moisture expands and contracts, prying rock apart from within. At the same time, tectonic stress from plate motion subtly deforms the land. Add gravity, pulling everything downhill, and you have a slow motion structural failure unfolding across miles of coastline. Dr. Patrick Barnard, a research geologist with the US Geological Survey, has warned in multiple studies that large sections of California's cliffs are far more vulnerable than they appear. Not because of a single catastrophic trigger, but because of cumulative strain. Years of it.
This layer
decades
here shows
of
clear
it.
stratification.
Invisible damage
weathering
adding up
patterns are
beneath
really
the surface. Monitoring stations have detected ground displacement rates in certain coastal zones, measuring several millimeters per year. That sounds insignificant, until you realize those measurements represent solid rock moving, entire land masses shifting, and movement that accelerates once thresholds are crossed, because cliffs don't fail gradually forever. They fail suddenly. One moment, stable. The next, gone. Residents along the coast have already witnessed previews. In 2011, a large bluff collapse in Pacifica sent thousands of tons of earth crashing onto the beach below. In 2019, another collapse forced evacuations when a section of cliff gave way beneath an apartment building. In Big Sur, landslides have repeatedly buried sections of Highway 1, cutting off communities for weeks. Each event seemed isolated, localized, explainable. But when scientists mapped them together, a pattern emerged. Many of the failures occurred in zones already identified as just geologically stressed. Areas where rock layers tilt toward the ocean instead of inland. Areas intersected by minor faults branching off the San Andreas system. Areas where groundwater lubricates the boundary between soil and bedrock, creating natural slip planes. And in other words, the collapses weren't random. They were symptoms, and the symptoms are spreading. High precision tilt meters installed along several coastal ridges have detected subtle rotational movement in certain slopes. Not enough for the naked eye, but enough for instruments to record. That rotation suggests the ground mass is slowly pivoting seaward, like a bookshelf tipping before it falls. The question haunting geologists isn't whether sections of coastline will fail. That's inevitable. The question is when, and how much at once. Because if a sufficiently large section destabilizes, the consequences won't be limited to falling rock. Large coastal collapses can displace massive volumes of water. Under the right conditions, that displacement can generate localized
Wind's
tsunamis.
picking up. Gotta get this reading.
Not the towering
Distance
waves
confirmed,
of
holding
Hollywood
steady.
imagination, but powerful surges capable of flooding beaches, harbors, and low-lying neighborhoods within minutes. Historical records show it's happened before. In 1812, a powerful earthquake near Santa Barbara triggered landslides that reportedly sent waves surging onto shore. In 1929, far from California but geologically relevant, a submarine landslide off Newfoundland generated a tsunami that killed dozens. These events remind scientists that land and ocean are not separate systems. They are mechanically linked. What happens to one affects the other. Today, offshore sonar mapping has revealed something else unsettling. Ancient landslide scars on the seafloor along parts of California's continental margin. Massive ones. Evidence that enormous chunks of coastline have collapsed into the ocean in the distant past. Events far larger than anything
Spike in Sector
recorded
4,
in
check the
modern
harmonics.
history.
Confirmed.
Which
Running
raises an
diagnostic now.
uncomfortable
All stations report status.
possibility.
Containment active.
Could it happen again? Dr. Gary Griggs, a coastal geomorphologist at UC Santa Cruz, has long emphasized that California's shoreline is geologically young and inherently unstable. Many cliffs consist of sedimentary rock, sandstone, shale,
Signal spiking on Sector
siltstone,
4. Correlate with the
materials
log.
far
Copy.
weaker
Aligning
than
now, it's
granite
clean.
or basalt.
Good. Monitor for drift.
They were never meant to stand vertically for long. Gravity is constantly trying to pull them down. Waves are constantly trying to undercut them. Tectonics are constantly trying to fracture them. It's a three-way assault, and it never stops. Recent LiDAR surveys, laser scans capable of detecting tiny changes in terrain, have revealed fresh fissures forming near cliff edges in multiple locations. Some extend several meters inland. Others run parallel to the coast, effectively outlining future collapse zones before they detach. To a casual observer, they look like harmless cracks in dry soil. To a geologist, they look like fault lines in miniature. Early warnings written in stone. What makes this moment different from the past isn't that cliffs are failing, it's how many warning signals are appearing simultaneously. Satellite deformation, data, ground sensors, erosion rate measurements, historical comparisons, independent methods all pointing toward the same conclusion. Stress along portions of the California coastline is increasing, not everywhere, not uniformly, but measurably. And then there are the anomalies researchers still can't fully explain. In certain monitored zones, ground movement doesn't follow expected seasonal patterns. Normally, coastal cliffs shift more during wet winters, when rainwater saturates soil and adds weight. But some sites have shown displacement even during dry periods. That suggests deeper forces may be involved, possibly tectonic strain accumulating below the surface. Another mystery involves micro-seismic activity. Networks of sensitive seismometers occasionally detect faint tremors beneath coastal regions that don't correspond to known fault lines. They're too small to be earthquakes, too consistent to be random noise. Some scientists suspect that they may represent tiny adjustments within stressed rock layers, like the creaking of a structure under load. If that interpretation is correct, the coastline may not be static terrain at all. It may be flexing. Most people imagine geological disasters as sudden events, earthquakes, landslides, tsunamis. But the truth is more unsettling. Catastrophe is often the final moment of a process that has been unfolding quietly for years. By the time visible failure occurs, the outcome was already locked in. That's what monitoring systems are trying to detect now. Not disasters themselves, but the precursors, signals that something is approaching a tipping point. Along sections of Highway 1, engineers have installed extensometers, devices designed to measure the widening of cracks in rock. Some have recorded gradual expansion over time, fractions of a millimeter, then pauses, then more movement, like a ticking clock with irregular beats. Transportation officials already know certain segments of the highway will eventually be lost to erosion. Maintenance crews repair damage, stabilize slopes, reinforce retaining walls, but these are temporary solutions. Human engineering can slow geological forces, it cannot stop them. The Pacific keeps striking. The plates keep grinding, gravity keeps pulling, and pressure keeps building. Computer models that simulate coastal stability suggest that once structural integrity in a cliff drops below a critical threshold, failure can occur with little immediate warning. A final trigger, a storm surge, a minor quake, even prolonged wave vibration can be enough to initiate collapse. That uncertainty is what troubles experts most, not knowing which section might go first or when. California has experienced devastating geological events before. The 1906 San Francisco earthquake reshaped the coastline in places, lifting some sections and dropping others. The 1989 Loma Prieta earthquake triggered landslides throughout the Santa Cruz Mountains. In 1994, the Northridge quake caused widespread ground deformation hundreds of miles from the coast. Each event demonstrated how interconnected the region's geology really is. Stress released in one fault can redistribute strain elsewhere. A shift inland can alter pressure near the shore. The Earth's crust behaves less like solid stone and more like a cracked shell under tension, which means coastal instability isn't just a coastal story. It's part of a statewide system of forces constantly adjusting beneath California's surface. And scientists know something else. The Pacific Plate is still moving. Every year it slides northwest relative to North America by roughly the width of a fingernail. That motion may seem trivial, but multiplied across millions of years, it has built mountain ranges, opened ocean basins, and triggered some of the largest earthquakes in Earth's history. Motion that's slow is unstoppable. Motion that powerful is inevitable. The coastline is simply where that motion becomes visible, where deep time meets human time, where forces older than civilization quietly reshape the land beneath modern cities, highways, and homes. Standing on a cliff edge at sunset, none of this is obvious. The horizon glows, waves shimmer, seabirds drift on the wind. It feels timeless, permanent, a safe. But instruments tell a different story. They show motion where our eyes see stillness. They show strain where do we feel solidity. They show change happening right now, beneath our feet, at a pace too slow for instinct to notice, but too fast for geology to ignore. Scientists aren't predicting the coastline will suddenly collapse tomorrow. That isn't how Earth works. But they are saying something more sobering. Certain sections are already in motion, already weakening, already progressing along a path that leads eventually to failure. The exact moment can't be predicted. The exact location can't be guaranteed. Only the direction is certain. Because coastlines don't crack all at once. They crack quietly, gradually, invisibly, until the day they don't. And somewhere along California's vast and beautiful shore, that day may have already begun. California's coastline, long perceived as solid and timeless, is quietly fracturing under the combined forces of tectonic stress, erosion, gravity, and rising seas. Satellite radar, GPS instruments, and laser terrain scans now reveal that certain cliff systems are not stable at all. They are slowly shifting toward the Pacific by millimeters each year. Though nearly invisible to the human eye, these movements signal weakening rock structures and deep geological strain. Scientists monitoring coastal zones have detected widening fissures, slope rotations, and unexplained ground motion patterns that don't always match seasonal erosion cycles.
Correlate with the log.
These subtle changes suggest that pressure beneath the surface may already be reshaping parts of the shoreline. Past collapses in places like Big Sur and Pacifica prove that failure can occur suddenly once structural limits are reached, sometimes sending massive debris into the ocean and triggering dangerous surges. Geologists emphasize that California's coast is inherently unstable because it sits on the boundary of the Pacific and North American tectonic plates. The land is constantly being stressed, fractured, and pulled seaward. Historical quakes and ancient submarine landslide scars confirm that large coastal failures have happened before. The most unsettling reality is not that the coastline might crack, but that in some places it already is, silently progressing toward a collapse no one can precisely predict.